Alright everybody, so I just wanted to welcome to you. This is about, I think, the fourth or fifth year that we've done Fire Talks. This is the fourth year that we run it. For those that don't know me, I'm Rex. I work for a large DoD contractor during the day, and I like to play at night on my website, www.divsec.com. So there's my plug. Okay, so, the first question is, what are Fire Talks? So these are basically 15-minute talks, and it's an alternative to the 30 or 60-minute. And kind of the whole philosophy is what I found in a lot of the longer talks, such as the one that Jason Street gives. Wow. I'm just kidding. There's a lot of background that they build up, and then they show the real good stuff at the end. So the idea with the 15-minute theme is you just have 15 minutes, and you basically got to jump right to the meat of your content. Okay. So we're just going to judge and vote the best talk, and these both go on. We're having them tonight. Right now, and it's Saturday. They're going to start whatever time. What was it? 6:30. So they're going to start tomorrow at 6:30. So we have 6 presentations tonight, and we're going to have 6 presentations tomorrow. So this is just a little bit of history. So this was actually a picture of the first Fire Talks. There were a lot of people that set it up, such as Michael, Sandhar, Angelo, or Catalyst, and also Muvix. And I think Chris Gates was also involved in it as well as many others. So the actual Fire Talks were held at the end of a hallway. And about the only, okay, there we go. About the only highlight that I can remember from that was Jack Daniel did this ad hoc talk, and it was the inaugural presentation of his sock puppets. So, Jack, where are you? So, all right, there he is. Maybe he can do a reprise. I don't know. So then we had 2010, which is Snowmageddon. So we had a lot of last-minute changes, but in the end, everything worked out. 2011, 2012 went awesome. So now we're up to 2013. Just wanted to mention and just give a big thanks to all the volunteers, so that Jack Daniel, Sarah Clark, Jason Oliver, and Nappy were helping with selecting all the talks that we had, recording. We also have Iron Geek over here, so these presentations or these sessions are going to be on his site probably. Well, they're probably there right now. Okay, and he somehow went forward in time and came back or something. So we have a timer and security. Do we really have? Okay, are the security people here? All right, everybody's watching. Awesome. Okay, so security people just make sure that everybody has a badge. Kind of forgot that one. Okay, so this is our quick schedule. Thin slicing black Swan. I have no idea what that's about. So then we're going to get. Sorry. It's some abstract reference. So then we're going to get the smartphone pen test framework. So
nobody cares about that.
Yeah, that's going to be Georgia, and then Tom Steele is going to be talking about Squid Shell, which looks awesome. Road Clown, where is she? There she is back right there. So she's going to be giving a nice quick talk on how to use capture the flags. Joe Klein. All right, so he's going to be doing some IPv6, or no, this is the final.
No IPv6.
And then the last one is, this is Wendy Nather is going to be talking about, and she's right there, and she's going to be talking about, this is going to be a very interesting talk. So anyway, so without further ado, we're going to start with presentations. Michele.
Props for the new song
Hi, I'm Michele Chubirka. My research partner couldn't be here today because he couldn't get a ticket. But I am Michele Chubirka, a senior network security engineer and blogger. I have a podcast called Healthy Paranoia because sometimes they really are out to get you. I usually speak on topics like effective neuroscience and the psychology of decision making. Ron Breck, my research partner, is formally trained in theoretical syntax. He has a master's in linguistics. He specializes in W3C, semantic web, RDF technology. He's written a book on RDF. He's probably one of the 5 people that actually understand it. Okay, I'm sure everybody... Let's see. 4 hours. I get more time, right? Okay, so everybody's probably seen this Verizon threat report. I think it's important to note, there are pie charts for those of you in the management realm. I'm sure that gives you some warm fuzzies. But an external party discovers 92% of breaches. An external party. Yikes. Then the second one is also from the, I think that's either from Verizon or the Trustwave threat report that came out. Again, I'd like to point out that it indicates that attackers had an average of 178.5 days within a victim's organization before detection. So why do we suck? Why aren't we getting this better? It sounds like, we have big data, we have all these fancy IDSs. I like to think of us more like security archaeologists. So a black swan event, hence my catchy title. Nassim Taleb calls it the unknown unknown. It can be predicted by probability theories. How often do we try to predict black swan events in security and fail miserably? This is an interesting line that I came across from a defense analyst. Military drone operators amass untold amounts of data that never get fully analyzed because it's too much. So we have all these wonderful drones, and we can't keep up with the data. This gives you an idea of how much data we're talking about. So from the beginning of recorded time until 2003, 5 exabytes of information. 2011, that much was created every 2 days. 2012, the prediction was every 10 minutes. This is from Dave Turek. He's in charge of the supercomputer development at IBM. He refers to this as digital kudzu, and if anybody knows what kudzu is, it was a perennial brought into the U.S. to prevent soil erosion, and it went crazy. Okay, so what are the current solutions that we use for this problem? The security issue is a SIM. Yay, a SIM. Everybody loves their SIMs. Predictions, we use logistic regression, Bayesian probability, huge amounts of data. We don't have enough time to process it all. Basically, one of the issues that I see with this is that we have an open world problem, but we're using closed world solutions, closed world assumptions on these problems. More staff, more money. Here's my proposal for an alternative model. There's a book by Malcolm Gladwell called Blink, and he talks about a concept called thin slicing, the ability of our unconscious to find patterns in situations and behavior based on very narrow slices of experience. For example, a fly ball. When you catch a fly ball, you do not calculate the trajectory of the ball. You're using a gaze heuristic to catch the ball. These are based on evolved capacities of motion tracking with your eyes and balance, the ability to move and balance. Here is an application of thin slicing. It was mentioned in Malcolm Gladwell's book. It's a case study of Cook County Hospital in Chicago, and if you've ever seen ER, that's what it was based on Cook County Hospital. The coronary care unit was overwhelmed by people coming in who had complained of chest pains or some other kind of symptom that gave the impression they might be at risk of a heart attack. And the doctors could not reliably, above just the basic chance factor, decide whether or not they were actually going to have a heart attack. It's a public hospital, they have limited resources. So there's a cardiologist named Lee Goldman who had created a protocol based upon an algorithm developed in partnership with some mathematicians. Cook County Hospital decided to implement this technique, and after 2 years of using a decision tree, hospital staff were 70% more effective at recognizing patients at risk. This is a situation where less information led to greater success, and I'd like you to remember that every time you walk into a hospital, they're dealing with highly, highly complex problems. You go to the emergency room, they're not, okay, what's your history? Oh wait, no, we need to get a little more data about the kind of problem this is. They're triaging you, they're getting you into an emergency as soon as possible. This is how first responders do it every day. This is an example of the typical green and mare fast and frugal tree. On the left, A, you see that's a typical cardiac care fast and frugal tree. On the right, that's for determining whether or not somebody should get bail. That's how it's been applied. Basically, a fast and frugal tree is different than a full decision tree as the ones that NASA use. The ones that NASA uses are information greedy. A fast and frugal tree is comprised of a search rule, a stopping rule. So the search rule looks up the factors of importance. The stopping rule stops the search if a factor allows it. And then the decision rule, classify the object according to this factor. It's a way to codify intuition that's informed by empirical data. So Ron and I came up with an application. We decided to use some semantic web technologies, the resource description framework. What I found interesting was this is a triple, these are two triples actually, in RDF, and it looks, an edge looks very much like a fast and frugal tree. They're based on, it's object-oriented, it's based on relationships or mental associations. What we did was we used packet captures, and the graphs treat each packet from a capture file as a discrete event with properties. The TCP header info is in a metadata model. It's an attempt to replicate human cognitive economy. We put this in a Virtuoso database, which uses Sparkle. So we used the Sparkle query language in order to traverse these large data sets while capturing similarities. If you don't know RDF, it's basically subject, predicate, object. Subject defines the event, predicate defines a characteristic of that event, and the object contains the actual value. Okay, this is supposed to be an animated slide. Let's see if it works. There you go. Here is the pseudocode for that. Subject, predicate, object. It's basically SQL, but slightly enhanced. So there's event 1. There's the property of event 1 source that we're looking for, and then we report on it. Here's an example of all source IPs and their destination IPs. For each source, count how many times it went to a destination, report source, destination, and count. It also has a web interface, Virtuoso, and that gives you an idea. It's a bit hard to see, but it shows you I think it should show you the return time, how long it took to respond for that query. It's very incredibly fast. So we can't fight all the unknowns, and I think that's the shift that has to happen. As I mentioned, we have an open world problem where there's information, a lot of information that we don't know. And when you have complex problems, complex solutions are great in hindsight, but not in foresight, in prediction, not a complex solution. So we need to focus on building good, strong infrastructures that minimize technical debt. We need to make sure we have defense in depth and we have airbags. Recognize the limitation of IDS and signatures, and investigate the creation of real-time fast and frugal trees. Right now, I sort of feel like our patient is dying on the table. I know this was a lot to take in. Does anybody, if I have some time, does anybody have any questions? Are we done? Or I have 5 minutes?
3 minutes.
3 minutes. Does anybody have any questions about our implementation? Yes?
Can you give a real world example of what you've done with it?
So far, it's in its infancy. It's very complicated to take semantic web technology and apply it to packet captures. Ideally, I would like to see more of a JDL fusion model where we take blobs of data in from multiple resources, not just packet captures. What I'm trying to do is look for patterns that could be a sort of fast and frugal tree. Does that make sense? And right now we're still at the exploratory stages. The Sparkle queries don't always work the way that we expect, but I guess that's what you do, right? You don't know what you're going to get when you try to take such divergent things and put them together. Yes.
What are the issues with looking for data that you want out of the queries and cherry picking it using these queries?
Yes. Right now, one of our biggest problems is getting data sets, large data sets, and we need them to be tagged, and I want to do side-by-side comparisons. I'd like to have the same data set, use the traditional technology, use our technology, hope and see how well we do at finding the same thing. Because we're trying to also build an impoverished query, the least, the smallest number of parameters that give you, because we don't need to know this is this type of attack. What we want to know is bad. This is worse. This is not so bad, this is the worst. I want to actually have a fast and frugal tree as much as possible. I mean, it sounds, I know this sounds a little probably pie in the sky to try to hope for that, but that's my desire.
P-value, what do you typically get?
I'm sorry?
In terms of like number of error percentage, what do you get query? What do you get?
I mean, right now our error percentage is probably sort of 50%. We're just not, we're not getting these queries quite right, and we don't have enough data to really, we're working with really old data sets from like 10 years ago, because that's all we get.
Meta-analysis on the data at this point.
I'm sorry?
Doing a lot of meta-analysis on the existing data.
Yeah, and it's taking a lot of time, and time that, our day jobs don't necessarily give us to do. Yes?
So ideally, looking years down the road, how are you thinking about building the decision making that says this is bad, this is worse, this is not so bad? Is that going to be a machine learning function or something that you
I knew that was going to come up, and no, ideally, how do you teach a machine to use heuristics? But real heuristics, smart heuristics of jumping to conclusions and take the best, all those kinds of, really simple heuristics. I don't know. I'm looking for research partners, so if you're interested, please let me know in a way to get a better application of this. This is, a first run, so. Thank you. I appreciate it. You can, here's my blog and podcast. You can,
So just a few minutes here, we just talked a lot about topics.